Thermodynamics. Thermodynamics is the branch of physics in which we study regarding exchange of heat and its conversion into mechanical energy. In this branch, we come across thermodynamic systems which are specified or interpreted in terms of parameters like pressure, volume, temperature, and internal energy. Thermodynamic system could be open, closed, or isolated. If it is open, it simply means that possibility of exchange of matter and energy both are there. If it is a closed system, it means energy could be exchanged but not the matter. And when it is called isolated system, neither the mass nor energy, nothing could be exchanged. That would be known as isolated system. Then we have to study four laws in thermodynamics. First of all, zeroth law. Zeroth law is simplest and the most fundamental law. Suppose there are two objects B and C, and there is third one, that is A. If A has equal temperature with B, A has equal temperature with C, then B and C will also have equal temperature. It's a very fundamental. You could say, now what's special with this? But well, this is law. When A and B, A has equal temperature with C and that with B, then B and C will also be having same temperature. And remember, when two bodies have equal temperature, they are said to be in thermal equilibrium. Then you must know, you must be aware of this term cyclic process. Cyclic process means you return back to the same point, same place, same state where from you started. Here, was it the case of mechanics, we would say cyclic process or cyclic journey would be return to the same point, same starting point from where the journey started. But here we plot the graph between P and V. It could be of any shape, but always one enclosure would be obtained when you depict cyclic process. So, cyclic process is always represented by enclosure on PV diagram. And now is the time for first law of thermodynamics. Zeroth we have covered. Now, first law. First law says that whatever heat energy is transferred to a system, that is utilized in two parts, in changing the internal energy and in doing the work on the system. Or you could say the change in internal energy of a system will be equal to the difference of heat transferred and work done by the system. Now, we have separate convention for all these three quantities, though all are energy. But we have to be careful while using this relation that unit should be single, either joule or calorie or whatever unit you adopt, but that should be same for all the three terms. This law is also said to be the another form of conservation of energy.